Snowflake just scanned 5 petabytes of data and answered your query in under 1 second. That's every book in the Library of Congress, times 400, searched before you finish typing. How? Snowflake doesn't treat your data like a warehouse you dig through by hand. It treats it like a library with a genius filing system. Before Snowflake, this was brutal. Teradata hardware cost millions up front. Queries on trillion-row tables ran for hours. Black Friday traffic spike. You provisioned 10x capacity permanently, even though you'd use it 1 week a year, like buying a football stadium warehouse just to store one shelf of books. Redshift Classic uses shared nothing architecture. Each compute node owns its own storage slice. Want more compute? You must physically rebalance data across nodes, hours of downtime, like a library where every reading room has its own private book collection. Add a room, librarians reshelve books all night. Oracle RAC tried shared storage instead, but now every node fights over the same locks, complex, expensive, slow under load. Row-based storage adds insult to injury. Ask for one column's total, and the database reads every column, every row. 99% of that I/O is wasted. Here's the fix, hiding in plain sight. Row storage stacks name, date, amount, city together, forcing full reads. Columnar storage splits each column into its own file. Need sum of amount? Snowflake reads only the amount file. For a 100-column table, that's not a small win. It's 99% less data touched. Here's what nobody tells you. Separating compute from storage should be slower. Every query now crosses a network to reach S3. But Snowflake caches hot data on local SSDs, caches full results in the cloud layer, and runs pure columnar scans. The extra hop disappears. You gain infinite elastic scaling instead. Remember the library? Snowflake splits it into 3 floors. Storage is the permanent archive in S3. Every book, forever. Compute is a fleet of independent reading rooms called virtual warehouses. Cloud services is the front desk. It compiles your request and finds exactly which shelf to check. Multiple teams, same books, zero fighting. A data science team spins up a 128-node warehouse to train models. Business analysts run a 2-node warehouse for dashboards. Both hit the exact same S3 archive at the exact same time. No locks, no contention, because compute never touches storage's territory. Turn off a reading room and you pay nothing for it. Snowflake bills per second of active warehouse time. Spin up a 4x large cluster for a holiday sales crunch. Crush the workload, then suspend it. Cost drops to 0. No stadium-sized warehouse sitting empty the other 51 weeks. How does Snowflake find the right shelf in a giant archive? Every table gets sliced into micro-partitions, compressed columnar files, 50 to 500 megabytes each. Every file stores metadata, the minimum and maximum value in every column. That tiny label is about to save you from reading petabytes. Query for 2024 data? Snowflake checks each micro-partition's label first. If a file's max date is 2023, it's skipped entirely, never even opened. Only files that could contain 2024 rows get read. It's a librarian glancing at a box label instead of unpacking every box in the archive. The math is brutal in the best way. A 5 petabyte table where only 1% is from this year? Pruning reads just 50 gigabytes, not 5 petabytes, a 99.99% reduction. Add columnar compression on top and you shrink data 5 to 10x smaller than row storage. Columnar compression compounds the savings. Similar values sitting next to each other, same city, same date, compress beautifully with delta encoding and run length encoding. Snowflake shrinks data 5 to 10x smaller than row storage. Less data on disk means less to move and less to pay for. Here's the first run path. A client sends a query. Cloud services checks for a cached result. Nothing yet. It routes the job to a virtual warehouse, which scans the data and computes the answer in 10 seconds. That result gets stored. The client waits, but never that long again. Run that identical query again tomorrow morning, 5 milliseconds. Same SQL text, same warehouse, no data changed underneath. Snowflake just hands back the cached answer. For dashboards refreshed hundreds of times a day, this single trick eliminates over 90% of compute cost. Zero warehouse time. Zero waiting. There's a second cache most tutorials skip. Each compute node keeps a local SSD. Frequently touched micro-partitions stay cached there. No repeated trips to S3. A data scientist running 10 queries on the same table barely touches cloud storage after the first one. Cold data gets evicted, hot data stays close. Compute comes in t-shirt sizes. An X small warehouse is 1 node, 1 credit an hour. Fine for a junior analyst query. A 4x large is 128 nodes, 128 credits an hour, built for petabyte scale scans. Same SQL, same data, wildly different horsepower. Two settings do the heavy lifting for cost control. Auto suspend shuts the warehouse down after a few idle minutes, zero charge while it sleeps. Auto resume wakes it in about 60 seconds when a query arrives. Multi-cluster auto-scaling spins up extra clusters when 500 analysts hit dashboards at once. Put it all together. A query for top 10 products by revenue hits cloud services first. Cache check, miss. It compiles an optimized plan, prunes irrelevant micro-partitions, and sends only surviving columnar files to a warehouse. The warehouse scans, aggregates, and returns results in under a second. Snowflake also remembers the past. Time travel keeps historical versions of every table for up to 90 days. Accidentally dropped a table? Query it as it looked 1 hour ago. Restore it to yesterday's state with one command. A library that never actually throws old editions away. Need a full production copy for testing? Zero-copy cloning creates one instantly, no data physically duplicated. The clone just points at the same micro-partition files. Only when you change the clone does it write new files. A copy of a 5 petabyte table, ready in seconds, costing nothing up front. Snowflake lets code come to the data, not the other way around. Snowpark runs Python and Java directly inside virtual warehouses. Data sharing lets one company grant live access to their tables to another Snowflake account. No export, no ETL, no copying. Just a shared key to the archive. DoorDash runs its entire analytics stack this way. Billions of delivery events, millions of restaurant menus, hundreds of millions of orders, all queried through Snowflake, transformed with dbt pipelines. When analysis spikes, they scale compute up temporarily instead of buying permanent hardware they'd rarely need. Warner Music Group pushes hundreds of millions of streaming rows through Snowflake from Spotify, Apple Music, and 200+ other platforms. It normalizes and aggregates all of it to calculate per-stream royalties for over 1 million artists. Without this architecture, that's weeks of Hadoop ETL just to pay musicians correctly. How does it stack against the competition? BigQuery is fully serverless and cheaper per query, but locks you into GCP. Redshift is fast but scales in fixed node increments, closer to old shared nothing pain. Databricks leans on Spark for heavier engineering. Snowflake's bet, elastic compute, any cloud, pure SQL. This architecture didn't just solve a technical problem, it built a business. Snowflake became the fastest software company ever to hit $1 billion in annual recurring revenue. Its 2020 IPO became the largest software IPO ever. The bet on separating compute from storage paid off in dollars, not just milliseconds. Here's exactly what to say in your next system design interview. Snowflake separates compute and storage into independent layers, so you scale query power without touching data, and micro-partition metadata lets the optimizer skip files it doesn't need. That one sentence signals you understand the architecture, not just the buzzword. Zoom back out to the library. The archive never moves. Reading rooms rent by the hour. The front desk finds the right shelf before anyone walks in. 3 independent layers, working together but never blocking each other. That's the whole trick behind querying petabytes in under a second. The part that surprises most engineers, none of this required exotic new hardware. Snowflake just refused to couple two things that never needed to be coupled: how much you store and how much you compute. That single decision is worth more than any indexing trick you'll learn this year. The library never needed rebuilding, just better organization. That's the whole story behind Snowflake's speed. Separate the archive from the reading rooms, and both scale free. If this made system design click, subscribe. Next we break down how Kafka moves 1 trillion events a day.